Welcome back. So today we're starting Unit 2. So our first section is 2.1, our conditional statements. You should have a foldable that looks like this, and it's going to go on page 77 in your notebook. Okay, so we're going to start out with our if-then statements. So I'll go ahead and zoom in here so it's a little easier for you to read. So a conditional statement is just a logical statement that has two parts. It has a hypothesis and it has a conclusion. Okay, so then we're going to start with the if-then form. So that's just a conditional statement that actually has the words if and then in it. Okay, so the hypothesis, that comes after the if portion, and then the conclusion comes after the then portion in our conditional statement. So if you look here at our example, if a polygon has 8 sides, then it is an octagon. So the if a polygon has 8 sides, that's our hypothesis. It's an octagon would be our conclusion. Now we have some symbols. So we have P implies Q. So if P, then Q. And we use this little arrow here. All right, so let's take a look at a few examples that we have. So the first one that we have on here says we're going to write the equivalent conditional statement in if-then form. It says a right angle is an angle that measures exactly 90 degrees. Okay, so we're going to change that to an if-then statement. So if an angle is right, so if an angle is right, then it measures exactly 90 degrees. So then it measures exactly 90 degrees. Okay, so let's try another one. This next one says, I bring my umbrella when it is raining. So when it is raining would be the if, then I bring my umbrella. Okay, so if it is raining, then I bring my umbrella. If this is happening, then I'm going to do this. Okay, let's look at the last one. Suzanne eats a snack if she is hungry. So if she is hungry, then she eats a snack. Okay, so if Suzanne is hungry, then she eats a snack. Okay, so that's how our if-then statements go. All right, so the next portion is going to be our converse, inverse, and contrapositives. All right, so we have some more definitions here. So a negation, that's the opposite of the original statement. And we use this little symbol here, so this is not P. Okay? A converse, we talked about converses a little bit earlier this year when we were talking about our parallelograms. We're just switching our hypothesis and conclusion. So instead of P then Q, now we have Q then P. Okay? An inverse, we're going to negate the hypothesis and conclusion. So not P means not Q. And then the contrapositive, we're going to first write our converse, then we're going to negate the hypothesis and conclusion. So we first switched and negate. So not Q implies not P. Okay? All right, so then we have a few notes down here. So in this notes, we have a conditional statement and it's contrapositive. Are either both true or both false. Also, the converse and inverse are either both true or both false. Okay, so they go together, they work together. So let's look at our examples here then. So the example we have on this one, we're going to start out, it says we're going to write the converse, then the inverse, then the contrapositive for each statement. Then we're going to decide if each statement is true or false. So we're going to write them first, then decide. Okay, so the first one, it says if a polygon has 3 sides, then it is a triangle. Okay, so our hypothesis is a polygon has 3 sides. Our conclusion, then it is a triangle. So for our converse, we're going to switch those. So we're going to say if a polygon is a triangle, then it has 3 sides. Okay? So that's the first one. That's our converse. So then we're going to do the inverse. So the inverse, we're going to negate these. Okay? So we're negating the original. So if a polygon is not, or excuse me, does not, this should be does not have 3 sides, then it is not a triangle. Okay? Alright, so then the last one that we're doing, that's our contrapositive. So that's where we're negating and switching. So I'm going to be switching the original, so that gives me my converse, and then I'm going to negate this converse. So if a polygon is not a triangle, then it does not have 3 sides. Okay, so those are our statements. So then we have to go back and decide whether those are true or not. So we're going to look at the first one. If a polygon is a triangle, then it has 3 sides. Do all triangles have 3 sides? Yes, so this is a true statement. The inverse, if a polygon does not have 3 sides, then it is not a triangle. If it doesn't have 3 sides, would we still call it a triangle? No. So this is a true statement. And then the last one that we have, if a polygon is not a triangle, then it does not have 3 sides. That is also true. Okay, let's do one more of these then. The converse. So we have if you play football, then you are an athlete. So you're going to put your converse first. Then you're going to put your inverse. Then you're going to do contrapositive. Okay, so you're going to work on those on your own. Bring those to class with you tomorrow. Okay? If you want to go ahead and pause there, I'm going to move on to the next section. So then you can rejoin whenever you're ready. Okay, so our next section is our biconditional statements. So a biconditional statement is a statement that contains the phrase if and only if. Okay, so we use this little symbol here where we have arrows on both sides. Okay, so it can go either way, if and only if. So definitions can always be written as a biconditional statement. So we have a few examples here. We're going to write the converse of each true if-then statement. If the converse is also true, then we're going to combine those statements to write a true biconditional statement. Okay? All right. So to start these out then, our first one says, if an angle measures greater than 0 degrees and less than 90 degrees, then it is acute. So the converse, if an angle is acute, then it measures greater than 0 degrees and less than 90 degrees. Okay, so if an angle is acute, then it measures greater than 0 and less than 90 degrees. So this is true. So that means that we're going to write a biconditional statement. So our biconditional statement says an angle is acute if and only if it measures greater than 0 and less than 90. Okay? Alright, so then the next one. If two angles are complementary, then the sum of their measures is 90 degrees. So we're starting out with the converse. So if the sum of two angles measure is 90 degrees, then they are complementary. Okay, and we talked about complementary earlier this year. So if the sum of two angles measure is 90 degrees, then they are complementary. This is true. So we are going to write a biconditional statement then. So our biconditional statement is if two angles are complementary, so two angles are complementary if and only if the sum of the angle measures is 90 degrees. Okay? So in the last one, if a number is an integer, then it is rational. So we're going to start out with the converse. So if a number is rational, if a number is rational, then it is an integer. So what are integers? Well, integers are whole numbers. So is this a true statement? Well, this one is not a true statement. So we're going to put not true. Therefore, no biconditional. No biconditional. Okay, we can't write a biconditional if the converse is not true. Alright, so let's continue moving on here. We've got a few more examples down here. So for this one, you're going to write the biconditional statement as a conditional statement and its converse. Okay, so the first one that we have here, it says two angles are adjacent if and only if they share a common vertex and a common side. Okay? So our conditional, if two angles are adjacent, then they share a common vertex and a common side. Okay? So then our converse, if two angles share a common vertex and a common side, then they are adjacent. Okay? So if two angles share a common vertex and a common side, then they are adjacent. Okay, so we're just taking the biconditional statement and we're pulling it apart into our if-then and then the converse of that if-then. Okay, so you have B and C. You're going to do these on your own and bring those to class with you tomorrow. So you have a few that you're doing on your own there. Okay, questions that you have, make sure that you're bringing those to class as well so that we can discuss them with the whole group. Have a great day. Bye.